Greetings of the day, dear students. In this video, one important topic we are going to discuss, that is the speed control of DC motor. Most of the times, as per your syllabus, if you are having laboratory, you used to do this experiment in your laboratory also. We will see what are the different methods, how to control the speed of a DC motor above its rated speed and below its rated speed. Here, if you observe, it can be achieved by variation of flux or flux control method and armature or rheostat control method. These two methods we are going to discuss in this video, and I will explain this circuit diagram and what are the formulas procedure. Right? We will discuss one example on how to calculate the speed at different conditions. Slowly we will discuss the armature or rheostat control method, and we will also do one example on this topic. Clear? Right. Now, if you observe, dear students, please observe from our previous basics, right? If you recollect, one second, I will show you. Now, if you observe, the back EMF is given by, if you recollect the previous basics, right? EB equals to 5Z NP by 60A. Back EMF EB equals to 5Z NP by 60A, right? From this formula, we can observe N equals to EB by 5 bracket of 60A by ZP RPM. In this formula, if you observe, EB indicates the back EMF, phi indicates the flux, A indicates the number of parallel paths, If you recollect the previous basics, now this A will be equal to the 2 if the winding is wave type, and this A will equal to the P number of poles if it is lap winding, right? And P indicates the number of poles. P is the number of poles, right? 5 already we have discussed. Flux EB is the back end. Z indicates the number of conductors, total number of conductors. So from this formula we can observe that, again with respect to the EB equals to V minus IA RA. By substituting that in the place of EB, we can see V minus IA RA by 5 into 60A by ZP. If you separate the constant, then N equals to K times V minus IA RA by 5. From this, if flux is reduced, then the speed will be increased. And also by changing the parameter RA, armature resistance, then also we can control the speed. So by varying the flux per pole or by varying the armature resistance, we can control the speed of the machine, speed of the DC motor. Coming to its classification, observe here variation of flux or flux control method, or by varying the resistance, armature or rheostat control method. Now let me discuss the variation of flux or flux control method. The flux that is established in the field winding because of the flow of current to the field winding. The current that is flowing to the field winding is ISH. Now by controlling the amount of this current flowing to the field winding with the help of some rheostat called field rheostat, we can control the flux. Observe from this equation, N is inversely proportional to flux. What does it mean? If flux is reduced, if flux is reduced, then speed will be increased. Right? Now By changing the ISH with the help of the field rheostat, we can change the value of flux, right? Shunt field current is small compared to the no load current. Compared to the load current. If you observe with respect to the ISH magnitude will be very very small. Because of that, I square R losses also will be small, right? Now, one important point is, uh, if a flux is low, speed will be more. At the same time, the flux should not be weakened too much. If it is weakened too much, what happens? The speed rises to the very high values. The speed rises to the very high value. So there is a limit on the maximum speed obtainable. And one more important point, using this method, we can obtain the speeds only above normal speed or normal value. How do you understand that? For example, if already the rated speed of the machine is some 1500 rpm, using this method, you can make it little bit greater than 1500 rpm. You cannot bring it down to 1500 rpm, less than 1500 rpm. So, one important point is, if you want the speed above the normal value, you can use this method. You can use this flux control method, variation of flux or flux control method, right? Now, let me observe one problem on this topic, right? A 500 volt shunt motor runs at a normal speed of 250 rpm, and armature current is 200 rpms. 200 armature current is 200 amp. Resistance of armature is 0.12 ohm. Calculate the speed when the resistance is inserted in the field winding and reducing the shunt field to 80% of normal value, and the armature current is 100 amps, and the armature current is 100 amps. Clear? So what he's saying is, if flux is reduced to 80% of the normal value and if the armature current is brought to 100 amperes, what will be the new speed? What will be the new speed? From the data given, the terminal voltage is already specified. The variable we have to use is V. Terminal voltage is 500 volt, right? Speed N1 250 rpm, it is already given. In the first case, the armature current is 200 amps, IA1 200 amps. Armature resistance is 0.12 ohm. Now the new speed will be how much? If the flux is brought to 0.851. At the same time, the armature current is brought to 100 amperes. Armature current is brought to how much? 100 amps. If you observe, N is directly proportional to EB by 5. N2 by N1 equal to EB2 by EB1 into Phi1 by Phi2, right? How you will get that? Simple. For example, N1 will be equals to some constant K times EB1 by Phi1. Similarly, for some other values, N2 proportionality constant, if it is removed, some EB2 by Phi2. What he has done is simply N2 by N1 he has taken. So obviously EB2 by EB1 into Phi1 by Phi2. Clear? Right. Now we are supposed to calculate the back EMF, how much it is developed. With respect to the DC shunt motor, if you recollect, the back EMF is given by the applied voltage V minus IA1 RA. V 500 volts. In the first case, armature current is 200 amps. Armature resistance 0.12 ohm. So the back EMF is 476 volt. Now, in the second case, the armature current is reduced. So the drop also will be reduced. Now the back EMF will be more. EB2 equals to 500 minus 100 into 0.12, 488 volt. 488 volts. In the data given, the new flux is 0.82 51 point 52 is 0.8 times 51. Therefore, N2 by N1 equal to EB2 by EB1 into 51 by 52, 488 by 476 into 51 divided by 0.851 by substituting these values. Clear? Right. Now, N2 will be how much? 250 into 488 by 476 into 1 divided by 0.8. It is 320.378 RPM. 320.378 RPM. Observe, by decreasing the flux, the speed has increased. Previously, it is only 250 RPM. Now it became 320 RPM. Clear? Yeah, that is observation we can make. So, dear students, observe in this entire session, right? You are controlling the speed by changing the amount of current flowing to the field winding. Because of that, the flux will change. Speed is inversely proportional to the flux. If the flux is low, speed will be high. But at the same time, you should not weaken the flux too much. If the flux is weakened or made weak too much, the speeds will become very high. And another important point, this method is useful for the speeds above rated speed. If you want to attain a speed above rated speed, then you can use this method. Clear? Right. Now the next method of controlling the speed is armature or rheostat control method. What happens is, observe in this diagram, no rheostat is connected to the shunt field winding. In the lab you can observe Z, and here it will be the armature A, and this is the line, right? Now in series to the armature, a rheostat is connected. By varying the resistance of this rheostat, the amount of current that flows to the armature can be changed. The amount of current that flows to the armature can be controlled by placing a rheostat in series to the armature. From this basic, N equals to K times V minus IA RA by 5. If we can change IA value, obviously the speed will change. In this process, the flux is kept constant. Right? Now, if slowly by increasing the resistance, if it is added, the speed, observe, it is getting reduced. If this is some reference value or rated speed, without any under no load, without any control, no resistance is added in the armature, right? By adding some resistance, slowly the speed is getting down, right? Here, this method is a wasteful or expensive method, because when the loads are changing, obviously the amount of current drawn by this also will change, and this is not suitable for rapidly changing loads, right? The speed will be changing with the load. So this method is very expensive also and unsuitable for rapidly changing loads. But the key point is, by connecting a rheostat in series to the armature, we can control the amount of current drawn by the armature. From this equation, if IA value changes, speed also will change. Clear? Right. Now let me observe one example so that we will understand in a better manner. A 240 volt shunt motor runs at 850 RPM. Shunt motor 240 volt. When the armature current is 70 amps, armature resistance is 0.1 ohm. Calculate required resistance to be placed in series with armature to reduce the speed to 650 RPM when the armature current is 50 amps. What he is asking is simply what should be the value of this resistance, so that already the machine is running at 850 rpm. Now it should be brought to 650 rpm. It should be brought down to 650 rpm. What should be the value of this resistance to be added? In your laboratory, you can observe this is armature A winding, and this is the field winding Z. This is the variable name we will give. Here you will apply the terminal voltage, and some current will be drawn by the machine I. Out of that, some current flowing to the armature IA, and some current will flow to the field winding ISH. Right? Here if you apply the KCL, I equals to IA plus ISH. Right? Now in the first case, the terminal voltage is 240 volt. Dear students, please observe whatever the problems are given in our exam. The variable names are important. I am repeating the same point number of times in whenever a problem comes. From the data given, we have to use the appropriate variables. Then only it will be easy for you for the substitutions or calculations. Right? The speed N1, use with the help of variable N1, 850 rpm. Armature current in the first case IA1, 70 amps. It is drawing 70 amps. Right? Armature resistance, the variable is RA, zero point 0.1 ohm. Now R should be how much? If the new speed is 650 rpm, and the new current drawn by the armature is 50 amps, IA2 is 50 amps. Right? Observe in this case the flux phi is kept constant. Right? Now N is directly proportional to EB by phi, N directly proportional to EB. So N2 by N1 equal to EB2 by EB1. EB means nothing but the back EMF that is generated here. Already you are familiar. Whatever the voltage that is applied, some amount will be dropped at the armature IA, RA, and remaining thing will be available, or some back EMF EB. Now EB equals to V minus IA, RA, EB back EMF. In the first case where the armature current is only 70 amps, at that case V minus IA, RA is equal to 233 volts. Now in the second case, for already existing RA, some new value of R is added, and now because of some new current that is drawn by the armature, this one will be our drop. Now this one will be our new drop across the armature. Now this RA plus R together you can call as RT. So indirectly this value will be equal to IA2 times new current, new armature current into RT. Now that one will be your new back EMF EB2, induced back EMF, V minus IA2 RT. We don't know how much is this RT value. We are supposed to find out that. Clear? Right. Now N2 by N1 equals to EB2 by EB1 equals to 650 by 850 equals to 240 minus 50 RT by 233. So RT is 1.236. RT is 1.236. Now out of this RT, what does it indicate? RA plus R. So what should be the new value of resistance to be added with the help of rheostat? Yeah, 1.26 minus RA, 1.26 minus 0.1, 1.136 ohms is to be added in series with the armature. Now by doing so, what happened? The speed which is already existing at 850 rpm came down to 650 rpm. The speed has been reduced by adding some additional resistance in series with the armature. In series with the armature. Clear? So this is how we can control the speed. Okay? Yeah. So this is what about the speed control of the DC machines, right? We have discussed the two methods, flux control method and armature or rheostat control method, right? Okay, students. This course is designed keeping in mind maximum university syllabus are to be covered. Depending upon the universities, some may offer this course in first year, and some universities are also offering this course in second year, and in some first semesters and second semesters like that. Yeah, the problem is for not all the colleges it is there in the first year. For not all the colleges this is there in the second year. Depending upon the availability of the not availability, depending upon the branches. For some people it is there in the first year, first semester. For some people it is there in the first year, second semester. Some colleges are implementing this course, the same course in second year, first semester. More or less, most of the colleges are having only in the first year. And either in the first semester, for example, for three branches, if they are having in the first semester, for remaining branches, especially for example, CSC, IT, CSC, IT, EC, uh, during one semester, mechanical, civil, electrical might be during some other semester, like that. Depending upon the branches, it is divided. And utmost care has been taken to cover all the syllabuses. If any topics are missing as per your college or university syllabus, please kindly send the name of the topic to the WhatsApp number, right? Which will be there in the website, so that it will be immediately added to the course. And at the same time, I request you to please kindly share this course link with as many students as possible, friends and friends in different colleges or different universities. My intention is this course has to reach the maximum number of students, and it should be helpful to the maximum number of students who are facing the difficulty in the basic electrical and electronics engineering course. From the statistics, we can observe that only 55% of the students are getting passed in the first attempt. More number of students are getting failed in this subject, right? If you have missed any classes, or if you're not understanding the concepts, this one will be helpful for you, right? Thank you.